Hi all, in this video we will learn about k-means clustering. K-means clustering is used to identify groups or clusters of data points in a multidimensional space. Consider this data set x1 to xn, which are consisting of n observations of a random d-dimensional Euclidean variable x. Now the goal is to partition the data set into some number k of clusters. Cluster, it means a group of data points whose interpoint distances are small compared with the distances to the points outside of the cluster. As shown here, the intra-cluster distances to be minimized and the inter-cluster distances to be maximized. Set of d-dimensional vectors mu, where k is equal to 1 to k, in which mu k, which represents the centroid, that is the prototype which is associated with the kth cluster. Mu k, it represents the centers of the clusters. Now we need to find some assignment of the data points to clusters as well as a set of vectors mu k in such a way the sum of the squares of the distances of each data point to the closest vector mu k is minimum. One of k coding scheme. For each data point xn, there is a set of binary indicator variables r suffix nk, may be 0 or 1, where k is equal to 1 to k, which describes which of the k clusters the data point xn is assigned to. So that, suppose if the data point xn is assigned to the cluster k, then r suffix nk will be 1. Rnj will be equal to 0 for j not equal to k. An objective function called a distortion measure is given by this formula. J is equal to summation of n is equal to 1 to n, summation of k is equal to 1 to k, r suffix nk, and this is representing the sum of the squares of the distance of each data point to its assigned vector mu k, and our goal is to find the values of this rnk and mu k so as to minimize j. Now this can be done through an iterative procedure in which each iteration involves two successive steps corresponding to successive optimizations with respect to r and k and the mu k. First we choose some initial values for the mu k. Then in the first phase we minimize j with respect to r suffix nk, keeping this mu fixed. In the second phase we minimize j with respect to mu k, keeping r suffix nk fixed. This two-stage optimization is repeated until convergence. These two stages of updating r suffix nk and updating mu k correspond respectively to the expectation and maximization steps of the EM algorithm. And to find the cluster center mu k that minimizes j, we need to find a point where changing mu k does not decrease j any further, which is indicating the local minimum. Technically speaking, first we need to take the derivative, that is to compute the partial derivative of j with respect to mu k. This derivative gives the rate at which j changes with small changes in mu k. Now set the derivative to 0. By setting this derivative to 0, find the points where j is stationary. Taking the derivative and we are finding mu k is equal to summation of r suffix nk xn divided by summation of r suffix nk. The denominator in this expression is equal to the number of points assigned to the cluster k, and so this result has a simple interpretation, namely set mu k equal to the mean of all the data points xn assigned to the cluster k. This is the reason the procedure is known as k-means algorithm. The two phases of reassigning the data points to clusters and recomputing the cluster means are repeated in turn until there is no further change in the assignments or until some maximum number of iterations is exceeded. In this picture, you could see the data set in 2D space, and this figure, it is showing how the data point assigned is either to red or the blue cluster. This is the E step. And in this figure, we could see each cluster center is recomputed to be the mean of the points assigned to the corresponding cluster, and this is the M step. These are the successive E and M steps to reach the final convergence of the algorithm. And this graph is representing the plot of the cost function J, and E step is represented by the blue points here, and M step are represented by the red points. The algorithm has converged after the third M step, and the final EM cycle, it is producing no change in either the assignments or the prototype vectors. And by this we can understand that we have reached the convergence of the algorithm. Now, let us see an online stochastic algorithm which can be derived by applying the Robbins-Monroe procedure. This is happening through a sequential update, that is, for each data point we need to update the nearest prototype mu k. This is the formula mu k, the new value, which is equal to the mu k, the old one, plus n into the data point minus mu k old, xn minus mu k old. Here, this mu k, the old value, it represents the current position or the value of the cluster center, and xn is representing the new data point, and we need to adjust the cluster center based on this new data point, and this n is the learning rate, because a small number that is controlling how much the centroid can move towards the new data point. And this factor xn minus mu k old, this is specifying the direction towards which we have to move the cluster center. This is the difference between the new data point and the current centroid. If the new data point is far from the centroid, the difference is going to be large. So in turn, the update will be bigger. In case if the point is close, the update is going to be smaller. This mu k new, that is the updated position of the cluster center. The formula moves the centroid slightly towards the new data point, but the amount of movement is depending on the learning rate. The k-means algorithm can be generalized by introducing a more general dissimilarity measure v of x comma x dash between the two vectors x and x dash, then minimizing the following distortion measure. The formula is this: summation of n is equal to 1 to n, summation of k is equal to 1 to k, r suffix nk v of xn comma mu k, which is the k-medoids algorithm. Here, this n is representing the total number of data points and k represents the total number of clusters. R suffix nk is a variable which is equal to 1 in case if xn is assigned to cluster k and 0 otherwise. V of xn comma mu k, it is representing the dissimilarity measure between this data point xn and the cluster center mu k. Let us see a problem. We are going to consider 8 data points P1 to P8. Using Euclidean distance, we are going to cluster the data points, 8 data points, into 3 clusters. Let us consider initial seeds or initial centers of the 3 clusters as P1, P4 and P7. Now, the thing is, we should know the formula for Euclidean distance. So, in case we have 2 points A and B, x1, y1, x2, y2, the Euclidean distance is computed using this formula, root of x2 minus x1 the whole square plus y2 minus y1 the whole square. This matrix is showing the distances between the 2 points. For example, from P1, if you want to reach P1, it is 0 is the distance, and you could see across the diagonal, that is from P1 to P1, it is 0, P2 to P2 0, P3 to P3 0. Here I have shown the upper half. The lower half is the same as that of the upper half. That is P2 to P6, we know it's 4.12. So obviously reaching from P6 to P2, it is going to be the same. That is P4 to P3 is the same as P3 to P4, for example. So using this matrix, we are going to cluster these 8 data points into 3 clusters. First, in the problem, it's already given there are 3 seeds, 3 centers of each cluster. So totally 3 clusters we know. In the first epoch, we need to find the distances of each and every data point to each of these centers, and whichever is minimal, we are going to place that corresponding data point to that cluster. That is, let us take point P1. So taking point P1, we need to compute the distances of point P1 to P1, P4, P7. So as you could see, P1 to P1 is 0, P1 to P4 is 3.6, P1 to P7 is 8.06. Out of the 3 distances, we know P1 is actually the center of a cluster. So obviously P1 belongs to cluster 1 only. Now let us take the point P2. So checking P2, distance of P2 with P1. So P2 with P1 is 5. Then P2 with P4 is 4.24. Then P2 with P7 is 3.16. Out of the 3 values, this is minimal. This is minimal. P2 is closer to P7, which means P2 will be placed in cluster 3. Now checking for P3, P3 is closer to the center of the second cluster. So P3 is belonging to cluster 2, P4 to cluster 2, P5 to cluster 2, P6 to cluster 2, P7 to cluster 3, P8 to cluster 2. So once this epoch 1 is complete, we can see P1 belongs to cluster 1, P3, P4, P5, P6, P8 belongs to cluster 2, P2 and P7 belongs to cluster 3. At the end of epoch 1, this is the assignment of the points to the various clusters. Now finding out the centers of the new clusters. For example, for cluster 1, there is only 1 point. So the point itself is the center of that cluster. But for C2, we have 5 points. So average of the x value of those 5 points, comma, average of all the y values of those 5 points. So center of the second cluster would be 6, 6. Likewise, center of cluster 3 would be 1.5, 3.5. In the second epoch, in the similar way when we compute, we end up in assigning P1, P8 to cluster 1, P3, P4, P5, P6 to 2, and P2, P7 to cluster 3. Finding out the centers of these 3 clusters, C1 center 3, 9.5, C2 6.5, 5.25, C3 1.5, 3.5. Considering the assignment of this P8, there is a shift from cluster 2 to cluster 1. In this epoch, we find that there is a no stabilization is there, and then the points are moving from one particular cluster to the other cluster. So there is a need to go for the next epoch as well. At the end of epoch 3, this is the assignment. And even in this epoch, we could find this P4 from cluster 2 is moving to cluster 1. And centers of these 3 clusters are 3.669, 7, 4.33, 1.5, 3.5. So the epochs will go on, and there are some stopping criteria which we need to follow to reach the convergence. Number 1 is, yes, centroids converge. There should not be any change in the centroids. Number 1, and there should be cluster assignments need to stabilize. There should not be any point movement from one cluster to the other cluster, and maximum iterations reached. So we set a predefined limit and we are running it for that many number of iterations. So these are all the 3 stopping criteria for this k-means clustering algorithm. So in this video, we have learnt about the k-means clustering algorithm. Thank you.